Okay, so I want us to try this question. It is a little bit tricky, but if we can do this one together, then we're going to do great on the test. So let's try this. So it says, I'll let you guys read it, and I just want you guys to try, actually, let's do this part together. So it says, when solid potassium chlorate dissolves in water, the solution feels cold. What are the signs of delta H and delta S for the dissolution of potassium chlorate? So I actually want us to do this in parts together. So it's saying, first of all, that solid potassium chlorate dissolves in water. Okay, so we already talked about this when it comes to entropy. And let's take a vote. Do you think that A, entropy should increase, or B, should entropy actually decrease here? Okay, so let's see what you guys said. Okay, let's take it up. So here we're told that we have a solid and it dissolves in water, right? We mentioned that a solid is very, very, very organized, very ordered. When it dissolves, you get ions spread all over the place, and you get water molecules all over the place too, interacting with those ions. So when it dissolves, there's a lot more disorder, right? Ions all over the place, all spread out. And so since there's more disorder from this process of dissolving a solid, the entropy has to be greater than 0. Okay, so that's how you can answer the first part of this question. So entropy, we're looking for entropy being greater than 0. And once you figure that part out, you can eliminate anything that says the entropy is less than 0. So this part is wrong and this is wrong. So I know that A can be eliminated and C can be eliminated. Now, how am I supposed to figure out delta H? So B says the delta H should be less than 0, but D says delta H should be greater than 0. So I want you guys to think about this, and then I'll give you a hint. So you can vote B or D, and then we'll take it up. Okay, so this one is tricky, but we'll take it up now. So okay, so let's see. So what is the hint now? How do I figure out if delta H should be positive or delta H should be negative? So the hint for this is that it tells us that the solution feels cold. Okay, if the solution feels cold, we talked about this yesterday when we were talking about calorimetry. We mentioned that, sometimes you get a solution. And we talked about how when you're dealing with the calorimeter, this is not related to this, but we talked about how you can do MCT for the solution. When you have the mass of the solution, the C of the solution, the delta T of the solution. And the whole point of kind of reminding you of that was that this is for the surroundings. So solution is surroundings. That's the key. Solution is the surroundings. So that's one hint that gets us closer to the answer. The other thing is that it says the solution feels cold. So we're feeling the surroundings, and the surroundings are cold. So do you think the surroundings gained heat or did they lose heat? So if the surroundings are feeling cold, surroundings lost heat. So then what gained the heat? The system. If the surroundings loses heat, the system will gain the heat. And we can go over a little bit of review. When delta H is greater than 0, that means you're inputting energy into the system, right? It's positive, adding energy. So we called that endothermic, we said, when you're adding energy or heat into the system. So that means the system gains energy. Whereas when delta H is less than 0, or you're releasing heat, so the system is losing heat, that was called exothermic. The system loses heat or energy. So here, because the solution feels cold, the surroundings are cold, we said. So surroundings lost heat. System is what gained the heat. And so if the system gained heat, we're going to say that the delta H is greater than 0. Heat was added to the system, and that's what we care about. And so that's why the answer here is D. So this one is a little bit tricky. There's a lot of different pieces of information you have to pay attention to. So first we knew that, okay, when a solid dissolves into water, that's a lot more disorder, so entropy increases. The second hint was that if the solution feels cold, the surroundings are cold, that means the system gained heat, and so delta H should be greater than 0 here. Okay, so let's try part 2. So part 2 is saying, okay, on your test, it wouldn't be part 1 and part 2. Just pretend it's a different question. So now that we know that, okay, delta H is greater than 0 and delta S is also greater than 0, answer this question. So I'll give you guys about a minute, 30 seconds to think about what you would put for this one. Okay, so let's start taking this one up. Okay. So here we know that delta H is positive and delta S is also positive. And it's asking us, is this reaction spontaneous? And in the different options, it says, oh, we know it's not spontaneous. Oh, it is spontaneous, or only at a specific high or low temperature, let's say. So how do we figure this out again? So we can do the trick I showed you just for understanding this equation. And then here we have a delta H that's greater than 0, we're told, and the entropy that's also greater than 0. So the second half of the equation is negative or positive, do you think? So we have a positive with a negative sign, so overall it's negative. So if I want this to be spontaneous, I need this negative part to be very, very big so that it wins, and overall delta G will be negative. So if I want that right side of the equation to be very big, the way that I'm going to get that is by increasing the temperature. So now that right side of the equation gets to be a very large negative, and overall delta G will be a negative. So I think that it's going to be spontaneous only at high temperatures. So I know I can eliminate A and B, because A and B say that it's non-spontaneous, first of all, and it's not non-spontaneous at all temperatures. We just figured out that it can be spontaneous, so delta G can be negative when the temperature is high. B says that it's spontaneous at all temperatures, which is not true. It's only spontaneous at high temperatures. So C and D are correct because they say spontaneous at high temperatures. But one big mistake that students often make on exams is they see that, oh yeah, this one part of the option's right, and then they select that and then they move on. but they forget to read the other part of the option. So notice that here, they're both saying different things here. So we have to figure out which of these is the better answer. So it's saying, okay, the reaction's spontaneous at high temperatures. And for a reaction to be spontaneous, you want delta G to be less than 0. So the answer would be D actually. Okay, so delta G is less than 0 when your reaction is spontaneous, and that's going to happen at high temperatures because what we just showed here.